Yeah, so welcome back guys, this is Madhav PVL, and in this video we are going to cover a revision for design architecture of algorithms. Now let us just start. So these are some of the basic things which we need to learn. So what is meant by an algorithm? So algorithm is nothing but a step-by-step procedure which defines a set of instructions to be executed. So set of instructions is an algorithm. It is a step-by-step procedure, and then these are some of the things which we need to just remember. They are input. So input is nothing but which will just give to the system. So zero or more quantities are externally supplied. The things which are externally supplied are inputs. Output is something which is at least one quantity is produced and is known as an output. Definiteness, each instruction is clear and perfect. Instruction clear and perfect. Finiteness, algorithm should terminate after a finite number of steps. Independent, it should have a step-by-step directions which is independent of any programming language. Independent of programming language. So independent algorithm should be available for any language. It doesn't depend upon any one of the particular language. So this is a basic thing which we can just see. So if we just give some input to the system, the algorithm will just get work and then it will just give some output. So this is a basic thing which we are just seeing since our first year. And then how to devise an algorithm. So basically, not devise, it's design. So how to design an algorithm. So basically, to design a new algorithm, we need to just follow some of the existing design strategies. So there are some existing design strategies. We need to just follow them for building some of the algorithms, and I just named them here: divide and conquer, greedy method, dynamic programming, backtracking, and branch and bound. So we are going to discuss about these things in this particular subject. So now how to validate an algorithm. So validation of algorithm is nothing but which we can just say like whether the algorithm is working perfectly or not, or we can just say like is it working with every language. So we can just validate an algorithm in different ways. We can even use the mathematical proofs for the validation. So how to analyze an algorithm based on performance measure. So we can just consider the space complexity and time complexity. So we can just consider this both for analyzing an algorithm. So validating is different with analyzing. So analyzing will just consider these two factors, whereas validating a particular algorithm will just depend upon testing that particular algorithm in different ways. And how to test an algorithm. So how to test the algorithm, debugging. So we can just debug the things like if we just give some sample input and if we just go step by step and if we just watch carefully regarding the movement of those steps, then we can just come to a conclusion. So that is nothing but the debugging, whereas profiling is nothing but executing some set of data. So we can just say like some test cases. So if we just apply some of the test cases, and then with the help of those test cases we can just come to a conclusion regarding this space complexity and time complexity. So that is nothing but the profiling. So representation and structure of an algorithm. So we can just describe an algorithm in many ways. We can just use a natural language, or we can just give something like an instructions, or we can just give something like a flow chart, or we can just use some pseudo code languages which resembles C and Pascal. So we can just even do these things. So we can just do in the natural language in English, or we can just give like some instructions, or we can do whatever it is required. So we can just define algorithm in whatever way it is required. So how to design an algorithm. So basically, to build an algorithm we require a problem statement, and then we also require some constraints. So constraints are nothing but the rules. So rules for that particular algorithm is constraint, and then the input to be taken to solve, the input is also required, and then the output to be expected. We need to just build up some test cases. So that is also important for the algorithm. So the solution to this problem, even a sample solution is required to build an algorithm. So in this way we can just design an algorithm, a problem statement, the constraints of that particular problem, and then input which is to be taken, and then output which is to be expected, and also a sample solution for solving that particular problem. So write an algorithm to find the sum of n numbers. So algorithm, we need to just define the heading like this: algorithm sum a and n is number of factors, sorry, the number of elements, and then a. So sum is equal to 0 initially, so for I is equal to 0 until n, so s is equal to s plus a of I. So I is elements, array of elements. So we are just going to do sum of these elements, and we are just going to return this sum. So in this way we can just write an algorithm for sum. So algorithm is nothing but it is just a rough representation of a code. So representing the code with a rough way is known as this algorithm building. Yeah, now let us see recursive and non-recursive algorithms. So basically recursive algorithm is nothing but which runs with a for loop, or we can just say like recursive algorithm will generally work in group. So actually it will just split up the input into two or more smaller inputs, and then it will just sort the things up. So it just splits the input. So recursive algorithm will just do that, whereas non-recursive will just go in a single go, like bubble sort. So in bubble sort it will just go in a single go, right? So in this way we can just say recursive and non-recursive. A recursive function is something defined with a termination condition, whereas non-recursive doesn't have any termination condition until we just find the proper solution or a goal state. So non-recursive algorithm does the sorting all at once. So here we can just see this Tower of Hanoi program. So basically this Tower of Hanoi concept is nothing but we need to just make the movement in between these three. If we just consider these three as stones, if we just try to move these three things up in between these three towers, we can just here is one constraint, like above the smaller one we can't just place the bigger one. So we can't just place a bigger stone upon the smaller stone. So here we have only one choice, like if we just see, if we just keep the smaller one in this place and then the bigger one in this place, sorry, the medium one, and then we can just see this greater one will be towards this side, and then we can just do one thing if possible. So we will just move the smaller one towards this side and we will just place it here. The smaller one will be placed here. So we will just remove all these things. So after placing the smaller one here, the bigger one will just go this side. So now again the smaller one will just come this side, and we will just place the bigger one here, and again the smaller one will be towards the higher side. So here it is nothing but the interchanging of these things can be done in this Tower of Hanoi problem. So movement of these things can be done here. So this is a basic algorithm for Tower of Hanoi. So here we are considering these as some of the variables. So if n value is greater than or equal to 1, so this is a conditional loop. So for rotation, recursion, so Tower of Hanoi, so this is a condition. So n minus x zy, so move top disk from the tower x to the top of the tower y. So Tower of Hanoi condition is this thing. We need to just make the movement from one tower to another tower with whatever way it is required. So in this way we can just write the Tower of Hanoi algorithm. So what is performance analysis? So performance analysis is nothing but, as we had discussed it before, they mainly depend upon the space complexity and time complexity of the working in that particular CPU. So what is time complexity? So time complexity is nothing but the sum of compile time plus execution of runtime. So here we can just see, so the time taken by a program is nothing but the time until the program gets compiled, and then the time it will just show the output, the execution time. So the compilation time and execution time overall sum is known as the time taken by the program. So the methods to compute the time complexity are step count method and tabular method. So this both doesn't give up more difference. So it is nothing but here in this step count method we will just involve the counting of that particular loop inside the program, whereas in tabular method we will just mention it towards the right side. So here we can just see the step count method. So iterative sum of n numbers. So here we can just see, so s is being assigned, so we will just do the count plus plus, and here we can just see the for loop is being run till n times. So count is equal to count plus 1, this will run for n times, and then this will also run for n times. The increment of the s will also run for n times, and then finally after getting out of the n, then this will run for one time, and this will just run for returning the value to the particular thing. So in this way the sum algorithm can be done. So the counting is nothing but here we can just say like the number of times the variables are being used and number of times the things are being used. So that is calculated with the help of this count. So algorithm of sum. So asymptotic efficiency. So we can just say like basically to mention the time complexity of a particular algorithm, we will just use these things. So big O of 2 power n, big O of n square, big O of n log n, big O of n, big O of log n. So in this way we will just use these things for the purpose of representation. So here we can just see like this is a graph. So in this way the asymptotic efficiency will be done. So big O notation, so it describes an upper bound of asymptotic growth rate of the function. Big O of O, big O of O is nothing but always the best case, whereas omega is nothing but it represents the lower bound, that is n log n. So these are some of the lower bounds, and then theta is nothing but it describes a tight bond on the asymptotic growth rate, so that is nothing but the medium value. So these are the three things in which the notations can be done. So these are basic notations like high, low and medium, and then algorithm. So in this way here we can just write up with some table, and then we can just mention the things. So here we can just see the variable is being used, so order of 1 here, and then the variable is being used till n plus 1 times, so it is being order of n plus 1, and then here it is being used again for n times. So the for loop is running for n times, right? So again it is being used for n times, and then y order of n. So basically we can just say like the exponential value will be considered as a major. So if we just say like it is of n square, then n square is more priority than that of n, whereas if we just see log n, even if we just get something like a log n, then also log n will be prioritized. So it is being prioritized in this way. So 2n will be first, n square will be second, and n log n will be third, and then last will be n log n. So in this way the things will be considered for a particular time complexity calculation of an algorithm. So in this way the things are being decided. So what is PRAM algorithm? So PRAM algorithm is nothing but the algorithm which runs in a parallel machine. So parallel machines is nothing but basically in the previous concepts the whole algorithm will just run in a one particular machine, but whereas in this PRAM algorithms we involve the concept of a parallel machines. So we require multiple machines to solve this problem. So we will just consider the problem, so we will just consider the problem, we will divide them into sub problems, and each processor will work on each problem. So all partial solutions are combined for the final solution. So in this way the solution is being completed within a less time with more number of machines. So single processor is a sequential algorithm. So sequential algorithm is nothing but just like a bubble sort, whereas a parallel algorithm is nothing but working with a different machine. So combination of solutions, partial solutions, is a parallel algorithm. So odd even merge, we can just consider this example. So it is based upon divide and conquer. So basically odd even merge is nothing but we are just going to merge two sets with the help of this odd even merge. We are just going to merge them with the help of this odd even merge. So it is completely based upon the divide and conquer. So how it is done? So basically x1 consists of a list of odd values. So odd values will be considered in the list of x1, whereas in the list of x2 it is being considered the even values. So all the even values will be considered in this x2. So x1 and x2 are sorted sequences to be measured by using 2m processes. So I will just discuss the algorithm after knowing about this problem. So basically these both are the sets x1 and x2, and then now we are just going to divide them in two ways. So x1 odd and then x2 even, and then x2 odd, x2 even. So in this way we are just going to divide them into odd list and even list. So after divide them into odd list and even list, we are just going to merge the two odd lists. So x1 odd list and x2 odd list is being merged. So here also the same, x1 even list and x2 even list is being merged. So we can just arrange them in some ascending order. So L1 will consist of the odd data and L2 will consist of even data. And then finally we are just going to shuffle this both things like 3, 2, 11, 6, 11, 8, 13, 14. So in this way we will just shuffle up things, and then we will just sort in between them, and we will just get the final value, final L value. So final L value is nothing but a complete sorted list. So now we will just get into the algorithm. So odd even merge. So if m is equal to 1, merge the sequence with one complete thing. So m is equal to 1, if you just consider only one value, so there is nothing but let us just forget about the step 0. So step 1, partition of x1 and x2 into odd and even parts. So x1 odd and x1 even, x2 odd and x2 even. So in this way I had just discussed it now, right? So in this way they will just sorted them. So recursively merge x1 odd and x2 odd, and then x1 even and x2 even. So we will just merge all these things, and we will just shuffle L1 and note that x1 odd, x2 odd, x1 even, x2 even are in sorted order. So they should be in a sorted order. So shuffle L1 and L2, compare every pair of m plus 1 and I plus 1, that is even and odd values, and then interchange them if needed. Output the result sequence. So in this way the values are being arranged at last. Yeah. And now let us continue. And now we are going to discuss about this PRAM sorting algorithm. And now we had just discussed it in the previous video regarding this odd even merge, and then now we are just going to discuss about the odd even sort. So basically I will just discuss the application first, and then we will just get to the algorithm. And then in exam they will just give something like this. So they will just give a set of values, and then according to the number of elements we need to just divide them into two groups. So we need to just divide them into two groups, and then we need to just sort them accordingly. So x1 dash, x2 dash are nothing but the sorted lists among this both things. And then again we will just divide them into x1 sort, and then x1 odd and x1 even, x2 odd and x2 even. And again we will just merge this both, x1 odd and x2 odd will be merged, and then x2 even and x1 even and x2 even will be merged again. And again these both will be placed here, 3, 2, 5, 4, 7, 6. So in this way they will be placed here, and again we will just shuffle the things in between them, and we will just arrange them in a particular order. So now let us just discuss the algorithm. So let us consider the x will be containing the value. So these are the inputs. So we need to just partition x into two parts. So x1 will just contain the values from k1 to kn by 2, and then x2 will contain the values from kn by 2 plus 1 until kn. So this you need to just remember this one single thing in this algorithm. So k1 to kn by 2, and then kn by 2 plus 1 to kn. So these both are the things, the partitions of the algorithm. So allocate n by 2 processor to x1 and another part of the processor to x2, and then we need to just merge x1 and x2 using param merge. So it requires 2m processors. So in this way the algorithm works. So basically this is an implementation of odd even sort. So string matching. So what is string matching? So string matching is nothing but here we can just say like if it is having, so if it is having a long sentence but we need to just find a bit of it, so if we need to just find something like a code, then the string matching is one of the thing which we can just consider that. So text editing programs frequently need to find all the occurrences of a pattern. So there will be a text in an array which is having a length of n, and then a pattern will be there, and we need to just search that particular pattern in that particular text array. So if p occurs with a shift s, so p is a pattern, so shift s and t, then it is a valid shift, else an invalid shift. So example, so here we can just see like T is containing this A, B, A, B, C, A, B, D, A, B. So if we are just searching this A, B, C in this particular thing, so here the occurrences occur at T of 3. So 0, 1, 2, 3. So A, B, C. Here it is occurring, and T of 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. See, here again it is occurring A, B, C, and again finally here A, B, C. So in this way the occurrences are being happened in this particular text array. So the applications are searching keyword in a file, so it is mainly used in the search engine such as Google or whatever it is. So type of string matching algorithms, there are different types of string matching algorithms. There are naive string matching, Robin Karp, Nuth, Morris, Pratt, and then string matching with finite automation. So first we will discuss about the naive string matching algorithm. So what is this naive string matching algorithm? So this naive string matching algorithm is nothing but the comparisons of a pattern in that particular text. So here we can just say like here A, B, D, we will just place A, B, D here. Only the A and B is being repeated, whereas D is not being repeated. So we will just increment the value of a P. So again this value will be removed, and then again it will start from here A, B, D. Here it is not matching, we will just increment A, B, D. Here also it is not matching, we will increment A, B, D. So it is matching. So after finding that particular pattern in that string, we will just found that pattern after 3 comparisons. So after 3 comparisons, let me just erase this thing. So this is comparison 1, this is comparison 2, this is comparison 3, and this is goal. So after 3 comparisons I found this goal. So there are total of 8 comparisons are done, 1, 2, 3, 4, 5, 6, 7, 8. I think we shouldn't consider one of the values, so we will just keep this aside. And now we will just get to the algorithm. So n is equal to t dot length. So t dot length is nothing but the value or the array, the string array, whereas m is nothing but p dot length, that is nothing but the pattern which we need to just search. So for s is equal to 0 until n minus m, that is here we can just say like n minus m is nothing but the last 3 values. The last 3 values are n minus mth position. So n minus m is nothing but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12 minus 3. So 12 minus 3 we will just get to this position. So after this onwards it is considered as the final position. So for s is equal to 0 to n minus 1, so if p of the value is equal to t of the value, then pattern occurs at that particular shift. So we can just write something like this. So running time, m comparisons will be done for n minus m characters. So running time which is obtained here is n minus m into m plus m. So we need to just remember this thing. So this is a running time which is obtained in this name string match algorithm. So advantages are the comparison of a string can be done in any order, so there is no requirement of extra space. So whereas the drawback is nothing but it is inefficient, it requires more time. So it has found a position, it doesn't find other from there, it again it gets from the starting. So this is the drawback or disadvantages with that. So the Rabin-Karp string matching algorithm. So here it is nothing but without checking every single value in that particular text file, we are just using some hash function. So we are just dividing up the things, and we are just searching the pattern with the help of a reminder. So don't get confused. So I will just show you here. So here we can just say like, so this is a pattern, these are the set of numbers, and then we need to just find 26. So 26 need to be found, and this is my hash value. 11 is my hash value. So I will just divide the thing with this 11, and I will just get some reminder. So I will just divide things here, and we will just try to get this reminder. If we just get this reminder, then we can just say like we found the value. But that is also having some another case. So this is having three types of cases. So like we can just say like 31 mod 11, which is not equal to 4. Like the value is not equal to 4, that means that is not 26. And here we can just say like 59 mod 11 is 4, which is equal to 4 but not 26. So that is spurious set. So spurious set is nothing but the reminder will be same but the value will not be. So that is nothing but the spurious set. Whereas there is one other case that is nothing but fine, we will just get this 26 value which is exactly equal to 4 and the exact match. So now this thing will be discussed in the algorithm. So there will be a pattern and a hash value and a text value. It works with the help of a hash function of our choice. So here we can just see n is equal to length of the text file, and then m is equal to length of the pattern. So n is equal to d to the power of m minus 1 mod q. So here we can just say like for I is equal to 1. So for I is equal to 1 until m, the length of the pattern, we will just divide the p with the q, and then we will just divide the t naught with the q. So what are this p and t naught? So they both are initially 0. So we will just divide the things here. So we will just divide the dp plus p of I mod q, and then dt naught plus t of I mod q. And for s is equal to 0 to n minus 1, we will just consider one thing. So if p double equal to t of s, p is nothing but the remainder which we will just get. So if the remainder is double equal to the remainder which we need to find, then we will just check whether the value is equal or not. So if the value is equal, then we will just tell it as a pattern occur, otherwise we will just perform the hash function again. That is nothing but the spurious set. So we will just move along, and we will just perform another hash function. So in this way we can just say like the p reminder is nothing but the value with which we will just follow in the pattern, that is nothing but 31. So 31 mod 11 is p, whereas t naught is nothing but the remainder which we need to find. So the remainder which we need to find is t naught. So in this way we will just conclude this algorithm, and then I think this made some sense. After finding it as a spurious set, we will just continue with this hash function, and then divide and conquer. So what is divide and conquer? So divide and conquer is nothing but we will just divide the list into sublists, and we will just combine after merging the sublists. So that is divide. So unsorted list into sublist with half of the size, and then conquer sort each of the sublist and merge the sorted sublists. So merge sort, first part, second part. So first part is a recursive sort, second part will also have some sort, and we will just combine these both, and we will just give the final sorted list. So we will just discuss now the algorithm. So we will just discuss step by step. So base case solve directly if it is small. Divide the problem into two or more smallest subproblems, recursively solve the subproblem and combine the solution to subproblem. So mid is equal to low plus high by 2, low plus high by 2. that is nothing but the middle value. So we will just apply the merge sort for low and mid, and then mid plus 1 and high. So we will just apply the merge sort here, and we will just merge these things like low, mid and high. We will just merge these things here. So what is merge? So merge is nothing but, here we can just say like while h less than or equal to mid and I less than or equal to high. So a of h is less than or equal to a of j, then b of I is equal to a of h. So we are just going to just merge the things. So if it is less than the value, then we will just interchange the things, else we will just write the things directly like this: b of I is equal to a of j. So if the value is smaller, then we need to just interchange the thing, otherwise we will just directly write the thing here. So if h is greater than mid, then we will just write from j to high, that is nothing but mid plus 1 to high. The values will be added here, and then so in this way we will just work on the algorithm. So if you just look, you will just get some clarity regarding that. Now we will discuss about the quick sort. So quick sort is nothing but, this is also one of the concept in the divide and conquer algorithm. So we will just pick some element as a pivot element, and we will just partition the thing according to it. So we will just see the example here. So I had just considered this 85 as the pivot value. So after considering that as a pivot value, this is an I value and this is j value. So until I is less than the pivot value, I will just increment the I value. So I is less than pivot value, I am incrementing it now. So 63 is less than 85, I will increment it now. So 95 is not less than 85, so I will just stay with this here. Now I will just come with the j value. Until the j value is greater than pivot value, I will just increment. So 98 is greater than 85, I will increment. 45 is less than 85, so I will just stop it here, and I will just interchange the thing. So that is a basic condition in this quick sort. So divide, partition of the array A into two subarrays. Conquer, recursively sort A and A using quick sort. So now this is a basic thing, so we will just discuss the algorithm. So this is a partition thing. So this whole thing is the partition thing, partition of low to mid and mid plus 1 to high. So we will just partition the things here, and we will also perform the quick sort also, and then we will just consider one of the element as a pivot element, and then we will just start from I is equal to 1 and j is equal to h plus 1. So while I less than j, I plus plus, while a of I is less than pivot, do I plus plus. So while a of I is less than pivot, I plus plus. So until a of I is less than pivot, I will just do this I plus plus, and then while a of j is greater than pivot, do j minus minus. So if I less than j, then interchange I comma j. Interchange is nothing but, we will just do it into one temporary value, and then we will just interchange the thing, and we will just put the temporary value into y. So this is a thing which we have just learned in our before classes. Yeah, now we will see what is meant by this Graham's scan. So to know what is meant by Graham's scan, we need to just know something like convex versus concave. So basically if we just consider 2 points x and y, then we can just say it as convex or concave with the help of the shape. So here we can just see like the line is just getting out of the zone here, right? So it is just getting out of the shape, whereas in the convex it doesn't go out, it will just stay inside. So that is the difference in between the concave and convex. So I will just discuss you the application, and then I will just get to know what is meant by that. So here we can just see in exam we will just get directly points like this. So after getting points, we need to just make sure we need to just draw some lines here, like from here to here, from here to here, here to here, here to there, here, here, and then here. I will just remove this thing, so it will be a bit easier. So we need to just draw something like this. So after drawing like this, we need to just mention them with some numbers. So after mentioning it with numbers, then we need to just draw or we need to just complete the things up here. So we need to just complete the thing, like we need to just join all these dots and we need to just complete it like a regular shape. Here it is looking irregular, like, right? So but we need to just make it regular. So how to do that? Basically there is a concept which is called as a non-left, like we are just moving from right to left, right? So this is right to left. So in this direction we are moving to just draw this particular thing. So now we need to just make sure like there should be no line which was coming like this, reverse to this, or against to its position, or going in a vertical direction, so it doesn't go like that. So we should consider that thing. So now we will just start drawing the thing. So we will just draw like this. This is also forming a shape here. So it is forming a shape, right? So this is forming a shape. So this is possible. So we will just draw it. And then now again we will just draw something like this. This also is forming a box, right? So now even this is also possible. And we will just draw like this. Even the next thing also possible. So we will just draw like this. But this is not possible because this space is becoming concave again. So let me just be clear. So this space, if it is like this, then this is forming a bit like a box. Even this is also irregular. So we need to just remove these lines. So this is not possible. So this is showing error because this is again forming an irregular shape, like a concave shape. So we will just join 3 and 5. Even that is also forming like an irregular shape. So we will just directly do with the 2. So we will just directly connect the 2 with the 5. So it is just forming some concave shape. So again we will just continue from here. Again we will just draw from 5 to 6. This is possible. And we will just draw from 6 to 7. This is not possible. So this is not possible. So we will just draw something like this. Even this is also not possible. So we will just directly connect the 2 with the 7. This is possible. So from now we can just say like this is forming a shape, a convex shape. So this is forming a convex shape. So in this way we can just come to a conclusion like this is possible with the Graham's scan. So we will just do like this. So that is the concept of the Graham's scan. So start a point which is guaranteed to be 1 at the hull. So hull is nothing but the minimum value. So we need to just consider which is at the minimum least position, and we need to just consider that as a starting point, and we need to just sort remaining points by polar angle. So what is meant by this polar angle is nothing but we shouldn't make that particular figure as a concave. We need to just make sure it is completely convex. So that plays a major role in this polar angles. And then point should be dropping points, but not opposite or cutting points. So they shouldn't be like this. So they should be just like a plane surface. So it is maintaining some regular shape. So in this way we will just design the thing. And then algorithm is nothing but let P naught be a point in Q with minimum y coordinate and leftmost point. So this is a leftmost point, right? So we'll just consider this. Let remaining points sort in counterclockwise direction. So push P0 S, push P1 S, push P2 S. So from I3 to M, do while top, next top, and so if this is a non-left, so if P makes a non-left form, pop S. So we will just push each of the thing here. So we will just push each line from here, and we will just check whether this is makes a non-left form or not. So if it is making a non-left form, then we need to just pop it. Otherwise we need to just push it up and draw a line. So in this way we are just going to design an algorithm. And then introduction to optimization problem. So optimization problem is nothing but we need to just find out the smallest cost solution. So these problems are to maximize or minimize some values. So it depends upon the question. If we need to just maximize the value, then we can just even do that. Basic notations. A feasible solution is any subset of original input that satisfies the set of constraints. So a feasible solution is nothing but a sample solution which can satisfy all the constraints. An objective function is an input for which feasible solution to be obtained. So objective function is something which is use it for maximizing or minimizing with the help of this sample solution. An optimal solution is the feasible solution. So a feasible solution is also one of the optimal solution, irrevocable. So once choices are made in a step, can't be changed. So this is the most important rule in the case of this optimization problem. So basically we will just discuss about the greedy method. So greedy method is nothing but it will just give some optimal solution, and then decisions are made one by one like in a recursive way, and then based on greedy choice property. So what is greedy choice property? So greedy choice property is something which we can just say like it doesn't think about the future. So it will just think about the present solution. So it will just check for the local optimal choices, and then best choice will be selected at the moment to solve. So it may depend upon the previous choices but not on the future. So it doesn't depend upon the future, it will just think about the present choices. So types of greedy problems. So subset paradigm. So paradigm G silent I think. So to solve a problem, greedy approach generates a subsets by selecting one or more available choices. So it will just select one or more available choices, and we can just choose the best one. So the example for this are knapsack problem and job sequencing deadline. So we'll just discuss that. And then order paradigm, some arrangement or order to solve the problem for the best solution. So we will just draw some table, or we will just consider each and every point, and we will just check for the best solution. So this is an ordered paradigm. So the example for this is single source shortest path. So we will just discuss all these three things. So control abstraction for a subset paradigm. So here let us just forget all these things. So for I is equal to n, so we will just consider x as one of the solution. We will just select a is the solution, so we will just consider that in the x. So if it is feasible, so if x is feasible, then then we can just do the union for the solution. Like we can just say like we can just consider that solution, else we will just reject that. So that is a greedy approach. So greedy approach is nothing but we will check whether the solution is feasible or not, and then we will just return the solution according to it. So if it is feasible, then we will just use that solution, else we will just reject. So we need to just remember these three things. Selecting solution, else remove it. So we will just do that in the greedy approach. Feasibility, if the solution is feasible according to that particular function, then we can just determine it with a solution vector. Otherwise we should reject it. So optimality, from set of solutions, particular solution which is minimizing or maximizing the objective function should be considered as the optimal solution. So differences between the divide and conquer and the greedy algorithm. So this is one of the conceptual question which we may just expect. So divide and conquer and greedy algorithm, it doesn't aim for the optimal solution, it tries to find the optimal solution. Divides the problem into sub problems, it will just work on different sets of solutions. So sub problems are independent, so same problem may be solved multiple times. Previously solved doesn't considered again. So it is recursive and inefficient, it is iterative and faster. So merge sort, quick sort, and knapsack problem and job scheduling. So these are the differences. So they will just divide the problem and they will just work on different solutions, and they will just all the sub problems are independent to each other, whereas this previously solved doesn't consider again. So it is recursive and inefficient, and it is iterative and faster. So these are the differences in between divide and conquer and greedy algorithm, and then we will just discuss about the knapsack problem. Yeah. Now we will see the knapsack problem. So basically knapsack problem is something which we had just discussed in our previous subject, mathematical programming, but here it is not that much complex. Here it is a bit simple. So now basically here we are having a bag which is having a weight m, and then we can just fit up to n objects in that, and then knapsack has a capacity of m, and we need to just maximize the profit by entering the elements into that particular bag. So we can just put up some things, and we need to just maximize the profit. So basically we will just get some values like this. This is the profits P1, P2, P3, and these are the weights W1, W2, W3. These are the weights. So we will just get something like the bag can have 3 items and the maximum weight is 20. So the maximum weight is 20, and now we can just randomly select some solution vectors, that is x1, x2, x3. We can just randomly select them. So I had just selected like 1 by 2, 1 by 3, 1 by 4, and then I had just calculated the weight and the profit. So it is just showing like 16.5 and 24.25. So a bag can handle a weight of 16.5 and it will just carry the profit of 24.25. So I will just increase the value from this. So I will just increase the value from this, and I will just try whether I can just get something more. So I am just considering the second solution as a 0, 1 and 1 by 2. So these values can be randomly selected. We will just randomly select one value and then we will just increment from that. So we will just calculate the weight. So the weight is exactly 20 and I am just getting a profit of 31.5. So 1.5 is obviously greater than 24.25, right? And the weight is also not maximizing, it is 20. So basically I will just consider the second solution because it is just giving me the optimal solution, more profit. So I will just consider this second solution. So this is an knapsack problem explanation, and then if we just get into this algorithm, so these are the things: m is equal to maximum weight, n is equal to number of items, w of I is nothing but the weight of the item. So algorithm for greedy knapsack. So from 1 to n we will just consider the weight of the knapsack bag as u. Weight of the knapsack bag as u. So for I is equal to 1 to n, we will just consider the weight of the item is greater than bag. If the weight of the item, so if item weight is greater than bag weight, then we will just simply break the loop. So we will just remove the thing here. Because the weight which is greater than the bag can't be carried, right? So we will just remove that particular thing. Else we will just do one thing. If x of I is equal to 1, then weight of the bag is equal to weight minus wi. So we will just cancel the weight and we will just update the value of the bag. So if I is less than or equal to n, then x of I is equal to u by wi. So wi is nothing but the weight of the item. So we will just calculate the weight value. So we will just add the weight value like this, and then we will just consider the weight value. So we can just remember only these things. So if we just remember these things and if we just remember how to work on that particular problem, then it will be a bit easier. So if you just remember this thing, then it is totally fine. And then job sequencing with deadline. So this is one of the important problem which we can just see here. So job sequencing with deadline is one of the problem. Here we can just see there are some set of jobs and they will also have some deadlines and profits, and we will be having only one processor. Like we can just assign a job only to a one person, or we can just only work on a one person's job. So it takes 1 unit of time. It tells how the total profit can be maximized. So I will just consider this example and I will just solve it now. So here if we just see something like this, so we first thing which we need to do is nothing but ascending order, decreasing order. We need to just make the profits arranged in a decreasing order. So I will just do one thing. So I will just do something like 300, 200, 190, 180, 120, 100. So I will just mention the values like this. So after mentioning the values, I will just mention the deadlines, that is 2, 5, 3, 3, 4 and then 2. Yeah, so these are the profits and then deadlines. and we will just mention even the job numbers here. So the job 4, job 1, job 3, job 2, job 5, job 6. So we will just consider this, and now here we can just see like the maximum number of deadlines, max deadline is equal to 5. So this is a maximum deadline. So we will just do one thing, we will just consider the values like this: 0, 1, 2, 3, 4, 5. So if we just consider the values like this, we will just increase the length. So if we just consider something like this, and we will just come in an order. So what is that order? So let us just see. So 300 is the maximum profit, so we need to just complete the job 4 before the deadline of 2. So I will just insert it here. Job 4 can be completed because it is free. So job 4 is done, so we will just put a tick mark. And then job 1, which should be done before 5, so I will just put that before 5. So job 1, this is also done, so I will just put a tick mark. And then job 3, which should be done before 3, but actually this should be done before 2. I had just made a mistake. So before 2, sorry, so it should be placed here. So J4 before 2, this is done, and J1 before 5. Work should be completed before the deadline, so we will just mention it before the thing. And then before 3, job 3, job 3, and then again we are having something like a job 3 which gives a profit of 180. But here we need to just remember one thing: job can be done before deadline. So that is possible. So a job can be done before deadline. So here we are just having a deadline of 3, but I can just complete the work in deadline of 1 hour. So I will just mention it here because the first slot is free. I can just complete, he need to just complete the work before the third slot, but I will just complete his work in the first slot. It doesn't become a problem, right? So I will just mention it in the job 2 in the first slot, and again we need to just put that in the fourth slot. So I will just put this here, job 5. So in this way we had just mentioned the things here, and finally this will just get rejected because it is not being fitted in any of this blanks. So we will just calculate the values of the total profit. So the values of the total profit are: J2's profit. J2's profit is 180 plus, J4's profit is 300 plus, J3's profit is 190 plus, J5's profit 120 plus, J1's profit 200. So this is the total profit which we are just getting from this solution is equal to total profit. Yeah, so this is the thing. In this way we can just work on this particular problem. So this is the thing which we are just going to work on, and then so here we can just see here they are considered that as a Gantt chart. So we had just mentioned that with the blanks, and they are just considering this as some chart, and they are just putting it in the deadlines, and they are just working on it. So they will just get something a profit like this. So we also worked on the same problem. So we need to just mention it like a chart, and if possible we can just write some steps if needed. So if the question is asked it for 16 marks or 8 marks, we can just mention it with some steps and we can just find out the optimized solution. So in this way we can just work on that particular thing. Yeah, so now we will discuss about the spanning tree. So basically a spanning tree is nothing but we can just say like if we need to just decide some route to reach a goal state, then we will just use the spanning tree. So a tree is something like an undirected graph, connected undirected graph. So a connected graph can have more than one spanning tree. It doesn't have any cycle, so it doesn't form any closed loop. So it will be like an open loop and it will just touch all the coordinates. So spanning tree should touch all the vertices. So minimum cost spanning tree, it is one of the all spanning trees where the cost is minimum. So basically this is a normal tree. So in this normal tree, if we need to just touch all this vertices, we will just, if we just start from A, so from A we have the options like 4 to D, 4 to C, 1 to B. As 1 is low, we will just choose this path. And from B we have options like 4 to D, 2 to C. So we will just choose 2 as the path to C. And then we have option like 5 to A, 3 to D. And now we will just choose this 3 because it is the lower value. So like this, so this is a minimum tree. So in this way we will just touch all the coordinates with a minimum cost. So the applications where this spanning tree is used as in the computer networks, civil network planning and cluster analysis. So for these 3 applications this whole thing is being used. And then now we will just discuss about the Kruskals method. So basically Kruskals method is something which we can just say like we will just find out the minimum cost vertices once, and then we will just arrange them in some ascending order and we will just join them accordingly. So I will just show you that thing in PPT. So here we can just see like, so this is the smallest vertices, like we can just say like this is the smallest one, 1 and 2 is the smallest one. So we will just check this. So we will just put a line in between these two, and the second smallest one is 9 and 3, that is 2. So it will just put a line even there. And then this third smallest is the 7 and 6, again it is 2. So we will just put a line again here, and the next smallest one is this 4, that is 3 and 6. So they will just put a line there. And then here we can just see the next one is 7 and 8, that is 4. So they will just put a line here. And then what are the remaining coordinates which we need to just touch? So we need to just touch 3 and 4, that is 7, it is having 7. So here also it is having 7, but if we just choose this path, then it will just bring a closed loop here. So we doesn't choose this path, so we will just choose this 3 and 4. So we will just draw a line in between them, and there is no choice rather than choosing the 4 and 5 because this is the minimum value. But before that we will just join 2 and 3. And then after joining 2 and 3, if we just join this one, then it will become a closed loop, so we will not join. So we'll just consider 9, and that will join 4 and 5. So basically the thing which we can just see here is we will just consider them in an ascending order. So we will just arrange them in lines. So we will just arrange those lines in an ascending order, and we will just join accordingly according to our requirement. According to our requirement we will just join those lines accordingly. So that is the Kruskals algorithm. And then we can just see this early form of minimum cost spanning. So here we can just say like if we just choose an edge which is having a lowest cost, then we need to just delete it from E. So if doesn't create a cycle, then we can just add it, otherwise we need to just discard that particular line. So if it is creating a cycle here, we can just see, so 1 and 8 is creating a cycle, then we need to just discard, otherwise we can just add it to that particular loop. So Kruskals algorithm. So Kruskals algorithm is nothing but here we can just say like J is equal to find U, K is equal to find V. So if J not equal to K, j equal to k, in the sense we need to just consider either j or k. So if j not equal to k, this is just for the purpose of a recursion. So I is equal to I plus 1, we are just incrementing the I. So t of I comma 1 is equal to u, min cost is equal to min cost plus cost of u comma v, union of jk. So here we can just say like minimum cost. So the minimum cost is possible, so we are just making it as a union. So we need to just remember this thing, this basic algorithm. And then time complexity of a Kruskal's algorithm is order of E log E. So Prim's algorithm. So what is Prim's algorithm? Prim's algorithm is nothing but we will just start from one particular vertex, and then we will just join them accordingly with the help of that particular value. So if the value is less, then we will just join the things, otherwise we will just leave it. So if we just start from 1, so we will just join 2 for it, because 1 is the smallest one, so we will just join the 2, and then from here we will just join the 8. So we will just join the 8, and from there we will just join the 2, and then from here we will just join the 7. Okay, fine. Yeah, so we can just consider either value. So here in this step we can just consider either the 7 or we can just consider this 4. Anyways, we will just connect the 7 later, so we will just connect the 4 now because it is having a smallest value. And then after that we can just connect this 2, and then from 7 we are going to connect the 8, and then the remaining values are 4 and 5. So we need to just consider it from 4 to connect to the 5 because it is having a minimum cost. So we will just connect it. So okay, before that the 7 is connected, and then the 9 is also getting connected. Yeah, so finally with the Prim's algorithm we will just start from the minimum most value and we will just continue it. We can just arrange them in any ways, but we need to just connect all the vertices with a minimum cost. So this is the thing here, and we can just see this algorithm. So if the cost of I comma L is less than I comma k, then near I is equal to 1, else near I is equal to k. We can just remove it, or either we can just use it. So the minimum cost matters. So if the cost is minimum, then we are just going to add that, else we will just remove that particular thing. So the time complexity is mentioned for different cases. And then differences between the Kruskal's algorithm and the Prim's algorithm. So it will just select the shortest edge in a network. So it will just select any vertex. So it is selecting a vertex and it is selecting the edge. So select the next shortest edge which doesn't create a cycle. So here we need to just search for the vertexes which were connected to at present vertex. So repeat step 2 until all vertices, repeat step 3 until all vertices have been connected. Kruskal's begins with the forest and merge into tree. So Prim's always starts as a tree. So order of n log n, order of n log n. So in this way we can just see the differences in between the Kruskal's algorithm and Prim's algorithm. Yeah. So now we came almost to the final concept. So now we are going to discuss about the Huffman coding. So before discussing about the Huffman coding, we need to just remember two concepts, that is fixed length code and variable length code. So I will just discuss it now. So fixed length code is nothing but if, in the previous days, if we need to just encrypt a value, they used to use those ASCII values for that particular characters. There are some ASCII values, right? So to avoid that, one concept is occurred, that is the fixed length code. So ASCII value will take 8 bits of data for one character. So for a one string character, it will just take 8 bits of memory to just encrypt that particular thing. Whereas this fixed length code is nothing but it will just we can just consider a one fixed value for every string. So we can just consider every word in a code as a same length. So every word with the same length is called as a fixed length code. So we can just fix like it should take only 5 bits of data for each word in the whole string. We can just fix it like that. Whereas the advantages and disadvantages are, access is fast because the computer knows where each word starts. So that is an advantage. Whereas disadvantages are sometimes the records are of large size, so the space will get slower to transfer, whereas variable length code, so variable length code is nothing but this is one another concept. So we can this is nothing but we can just change the ASCII values according to the frequency of occurrences in that particular string. So we can just say like in the name of Madhav, A is occurring 2 times, so I will just put some small ASCII value for that A. So because the A is repeating for 2 times, so we can just even use this concept. So variable length code is nothing but giving a short code for a frequently occurring characters. Further advantages is it can work perfectly with frequently occurring characters. Disadvantages is difficulty to identify characters, where it ends and where it begins. So the combination of this both is this Huffman coding. So Huffman coding is just for the purpose of shortening the message by giving the codes for that particular messages. So I will just discuss the application once and then I will just get into the topic. So here we can just say like we need to just scan the whole string value. Here we can just see Erie I see near lake plus stop. So we need to just scan the whole thing and we need to just sort out or prioritize the characters based on number of occurrences. So this is the frequency. Here the capital E is occurring only 1 time, whereas small e is occurring 8 times. So it is occurring 8 times. It is the most frequent value in this particular whole text. And then R is occurring 2 times, I is occurring 1 time, space is also occurring 4 times. Space is occurring 4 times, and then full stop is also occurring for 1 time. So in this way we need to just note down the frequencies of that particular characters in this text. So we need to just build some Huffman code tree. So Huffman code tree is nothing but we will just build that particular tree with the help of this number of occurrences. So we need to just perform a traversal. I will just discuss it now. So I will just build a queue, just a simple queue like this. So the most occurring character will be towards the complete right and the least occurring towards the left side. So I will just arrange this whole thing in a queue based upon this frequencies. So these frequencies will be arranged like this in a queue. So after arranging this I will just do one thing. So the thing which I will just do is I will just add this both. I will just add this both and I will just get the frequency value as 2. So now I will just add this both and I will just place the 2 in between 2 and 4. So I will just place the 2 in between this 2 and 4. So in between 2 and 4 this both are placed. So now I will just add this both Y and L. It will again give the frequency of 2. So again I will just place in between this 4 and 2. 4 and 2. I will just place in between them. So again I will just add this both 2 and 2, R and S. Again it will just give some 4. So R and S also will be placed in between this 4 and 8. And then again I will just add this N and A. So it will just give the 4. So I will just place in between this 4 and 8. So again I will just add these both, that is 2 and 2. So it will give E I Y L for 4. So I will just add that in between this 4 and 8. And again I will just add this both 2 and 4, which will give 6. So I will just add K full stop SP here in between this 4 and 8. So I will just add something like this 6 here, and I will just add 4 and 4. So I will just add this 4 and 4 and I will just add in between this 6 and 8. So I will just add the whole thing. So even I will just add this 8 and 8, which will give 16. So I will just add in between them, and then I will just add 16 and 10, which gives 26. So this is a whole final Huffman tree. So I will just add upon the queues which were towards the left and I will just place them towards the right according to the frequency. So I will just do that thing, and now I am going to just encode the value. So how to encode the value? Here we can just see like we need to just place zeros towards the left side and we need to place 1 towards the right side. So here it is 0 1 0 1 0 0, sorry. Okay, yeah, so in this way we are just going to place zeros and ones, and then now if we need to just check the value for this E, then we need to just do one thing. We need to just start it from here. 0 0 0 0, 4 zeros will give E. So if I need to just check the value of I, 0 0 0 1, so it will give the value of I. So in this way I am going to just calculate each and every value, and I will just note it down there towards the left side, and we can just write this like this. So we can just write this text in the form of this code. Here we can just see the most occurring E will have a smaller code and remaining will have some large codes. So decoding the file, decoding also is one of the important things. So decoding in the sense it is nothing but, here if we can just see, like, so this is an encoded message. To decode this we need to just make sure if it is having 0, then we need to move towards the left side, and if it is having 1, we need to move towards the right side. So we can here just see the 4 zeros. So 0 left 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 left, so it will give E. So the first letter is E, and again 1 0, so 1 0, it will give small e. So in this way we are just going to decode the values. So I will just discuss now the algorithm. So we need to just create something like a leaf node, and we need to just create something like a recursion, and we need to just add the minimum frequencies. So after adding the minimum frequencies, then we need to just attach them towards the right child, and we need to just repeat these 3 and 4 steps until we just get the final big tree. So until we get the final Huffman tree, when we need to just add up these frequencies. So the time complexities are, the minimum time complexity is order of n log n, then towards the left side it is order of log n. So in this way we will just see. So the applications are, works well with text and fax transmissions, and then which is used for several data structures, whereas disadvantages is nothing but encoding are suitable only for encoding text, and image files and programming files can't be encoded with the help of this. And Huffman encoding is relatively a slower process, because it is a 2 passes, one from building statical model and another from encoding. So these are the advantages which we can just see. So in this way we can just work on this Huffman coding.